get started for now. Cool. So, hello everyone. Welcome to week 5. Wow, holy crap! Welcome to week 5's AMA. This week with us we have Amanda. Amanda is currently a high school teacher at Intern School here, and in past has done a lot of different shenanigans, which we'll hopefully hear out today. Some of them including web development and working with other volunteering groups. Web development at Microsoft and other sort of stuff like that. But yeah, I think we'll start it off. So the first question I want to ask is quite a really difficult question, and it's quite a traditional question that we get around to asking. For context, we recently had our first year camp where we take a bunch of first years to the wilderness, and we have just like a fun few days. And we have camp leaders for those, so older students who like look after the younger students. And one of the questions we ask on that is like, is pineapple on pizza? And I think it was a 400-word section you have to fill in the response there. Does pineapple belong on pizza? What is your response there?
It definitely belongs on pizza. I'm sorry. I understand that the Italians disagree with us on this, but we have improved at historical foods for the better with pineapple.
Correct answer. You have passed the test. There are some people who very much disagree, but I think that is the correct answer as well. Tom, do you want to take the next question?
Next question? Sure. Which one? Was Shrey always the fantastic human being?
Okay. You just muted out in the middle of that question.
Oh, sorry, we're both muted. Also, I did not realize the next question was about me. How did that get in there?
So
it has like 5 likes now.
Muted halfway through the question about Shrey. So
the question was Shrey always the fantastic human being we know today, or was he actually a miscreant in high school?
Okay, so to be fair, Shrey didn't attend my high school, the high school that I taught at. I taught at Tara Anglican School for Girls, and Shrey is therefore an old girl of Tara Anglican School for Girls. Because we did an external subject, so he was entering from his school to do, because they didn't offer software, and so miscreant would not be a word that I'd use. And doing all of the work on time, very conchy, was Shrey. I have no idea if that's still the case. Is that still the case?
On time is definitely the right word there. Like right on time.
Okay.
I had a lab this week that I submitted like literally 10 minutes past the deadline, so very on time / before time. Cool. Kai,
yes, here's our president being a great influence. I feel like maybe I should ask a serious question to you as well before Kai asks the question.
Mm-hmm.
Speaking of high school, what are your thoughts on the current software design and IDT syllabus?
Okay. So I don't actually know the IDT syllabus very well. Sorry, did you say IDT or IPT? I don't know the IDT syllabus very well, which is the IT subject. Okay, so IPT and software are both very old syllabuses and are overdue for review. And we got some draft syllabuses out a little while ago, and they were like a bit of a mix of a lot of different ideas. Like, we need to redesign the syllabus, but let's put everything we've ever heard of onto this piece of paper. And so then it went through a review process with the community, and lots of teachers gave feedback, and lots of university representatives gave feedback, and textbook writers gave feedback, and then everything ground to a crashing halt when the New South Wales education, when NESA needed to do a curriculum review to check how all of the curriculum were tracking against global measures and benchmarks, and so everything got put on hold. So we had intended, I think I would have been implementing the new syllabus in its new form for next year, and then we've just been delayed a couple more years because of the review, which does cause pain because it's been around a really long time. It only got tweaked in, I think it was 2012, and that was a really minor tweak. A couple of things got changed, not the entire rebuild that it needed, and so looking forward to when we're going to have something that we can really embrace the new millennium that's 20 years old. Yeah.
Cool. So I guess one of the major reasons that we wanted to get you in today was because you've had quite an interesting sort of career, sort of life progression path, going through a bunch of different hoops to do a bunch of cool stuff. So one of the questions is like, what have you done? Like, what? Give us a brief rundown.
A rundown of the last 20 or so years. Sure.
Yeah, pretty much.
Okay, so I wasn't brilliant at school. I wasn't the super conchy kid who always got things in on time. I think famously, I didn't know one of our option topics going into my economics exam in the HSC. And so I was the kid that always had the not working to her potential thing on the report. And so the only thing I knew when I left school was that I wanted to do something computers, because that seemed fun. And I liked mucking around with bulletin boards. And yes, I'm going to be giving away my age, something chronic in this discussion, but, and making mini games in whatever I could do, and playing with logos. So that was when I left school. I knew I needed to do something computing, but I didn't know exactly what. And I got into computer science at Macquarie. So, and I got a traineeship. So I was offered this place where I could work from 7 till 3 full time, and then do university at night doing computer science. So get up at pre-dawn, get to work all day in a place where we put together computers, which actually happened in Australia. Osborne Computers did actually assemble computers in and ride. And so I worked putting together computers all day, and then I'd go to Macquarie University at night and do from 6, eat something madly, do from 6 till 10, which was lecture plus prac plus shoot, and then do my homework in the all-night Maccas on the way home, and then do it all again tomorrow. That was my first year of uni, and it was a little hard. You can imagine. That's quite a difficult thing to do. We're sitting in a lecture theatre at 9 o'clock at night with a lot of people who work, because mature age students are very commonly night students, but also a sea of males. This is a while ago, and I didn't even see another female in those classes. Probably it would have been different during the day, but yes. So not having any connection to people, so that when having a society, having something like the Girls Programming Network, someone to talk to about my homework, about my assignments. A bunch of us would cruise the recycle bin next to the printer in the labs at night to see if we could get some help on the thing that we're trying to build for our assignments, which I'm sure never happens anymore. But that was definitely how I got over some of the roadblocks, because Stack Overflow didn't exist, and the internet was like in its baby stages. So we would have to learn from pieces of paper, and so I did Pascal and QBasic and I think it was mostly, and a little bit of COBOL at uni, and I did maths like first year and second year maths, and it was second year maths that where everything hit the fan. Second year maths, when you are doing your homework at night in the local Maccas, and you don't have connection to other humans, so you don't have anyone to ask, you don't have anyone to help, meant that I actually set a terrible example and failed the same subject twice. And at Macquarie University, you're not allowed to fail the same subject twice. You get asked to please come back when you are more mature. So I went out and I hit the workforce. I did customer service, and then started training in like IT help desk type stuff, because I was still quite interested in computing. And I knew a lot of super geeks, and I could do stuff with computers, but I just didn't have the training. And then a university opened a block from my house. The University of Western Sydney opened their Parramatta campus, and so it seemed like a sign from the universe that I should go back and do that thing that I started that I didn't quite finish the first time around. So they did, they had a slightly different bent on computing. It was business computing, which is what I'd like to think IPT is meant to be. A lot of database, a lot of some like actual business courses so that you can understand why people need to know computer stuff, why they have to have stuff that works. You do some accounting, you do some marketing. So it was actually packaged up quite well in that businesses actually think that you know stuff, rather than sometimes computer science degrees, you come out and you have no practical knowledge of how a place works at all. And so it's hard to empathize with users in that instance, because you know the theory, but what do they actually need in practice? So I'd been working all of this time, and so I had a whole lot of work experience, and I was now doing my degree again, and I met my husband, which was quite handy, in a computer lab late at night, and so those highly romantic computer labs, and so we finally I had a bit of a network, and so we started getting high distinctions and being those vomitous mature age students in the front row asking all the questions after the uni students are well done and want to leave now, and so actually it was more successful. And in the meantime, in the back end, in my work life, I went from customer service to IT support to network support to database support, and I taught myself database using Access at home, because Access 2.0, long time ago, but Access 2.0 was actually a pretty good program. It didn't have anywhere near the helpfulness that Microsoft has built into it now. And so you could actually learn SQL, and you could build yourself little apps that like all of my home budgeting stuff I built into Access, and then I'd make little mini like library systems and things like that. And there wasn't a lot to do. And so taught myself database. And because I had database skill, I was able to get this database support job at a small, medium enterprise in Rydalmere. And from there, I got offered a position at Microsoft. And I still didn't have my degree. I was chipping away at it at night. And I think when you tell anybody that you've been basically at university for 8 years straight, they start to think you might have some staying power. So yeah, I got into Microsoft as a database, what they called a database developer, which I guess these days you'd call like a data scientist or a data analyst or something like that. And my job was, they hadn't invented Power BI yet. So I was making front ends for SQL database queries. So I was using ASP, just at the cusp of, on the cusp of ASP.NET, and working in the Global Technical Support Center, pulling out all of the data from the enterprise customers and munging it in different ways to make it useful for the business managers. And so all of that businessy stuff that I'd done at uni was really helpful, because it meant that I could really understand what they were trying to do, what they were trying to get out of that information. Yeah, so that was where I ended up. And then I got, well, I guess it was a promotion. I went for a job as a program manager, which is kind of like a project manager, but your project doesn't change. And so you're managing deadlines, and you're managing resources, and you're trying to get stuff done to budget and things, working with the global Microsoft business. And that was kind of fun, but it was also like, it was moving away from solving those problems that I really enjoyed being a developer, you know, where you go and have a cup of coffee and stare out the window to try and, you know, untangle that thing that's really bugging you in the page that you're trying to build. And so after a while, that's right, I actually had a baby. So that was, I have two children, and my first one I had while I was at Microsoft. And I probably would have gone back to Microsoft and kind of moved sideways again to get back into problem solving. But that was in the mini baby boom, which you may not know existed, but it was very, very difficult to find childcare. And so I would have had to have Sam in 5 different places for 5 different days. And that seemed like a difficult thing to do. And so instead of going back to Microsoft, I decided, my husband and I decided that we'd have 2 kids fairly close together, and I'd just take the time and be the mum for a couple of years. And since I was home and I'm not very good at sitting still, I joined uni again and got my graduate diploma in education. I think it was the last group that was allowed to get a grad dip of ed. I think that it has to be a master's now to get a teaching qualification.
Yeah, teach high schools.
Yeah. So I was grad dip ed of teaching, which was lucky. It's not that many units extra, but it is a couple of extra units to get your master's. I have one now. It's fine. But yes, I went and did my grad dip ed in computing. I probably should have, in hindsight, done computing / maths or computing / HISI or computing / something else, because for a while there, it was a bit tricky finding places that would hire computing teachers. It's getting easier. I think there's quite a dearth of computer trained teachers now. So that's, I guess it's beneficial. But at the time being, I probably, had I got some advice, I would have probably gone with 2 subjects rather than 1. But it just means that I've been able to focus. So I got my first job at Tara Anglican, and I was there a really long time. And then I got to work on a really cool project at Sydney University where we were funded by the government to develop some really good training materials for teachers and classroom materials for them to use in the classroom. And so I spent 3 years doing that. That was a 3-year contract, so I didn't really fight to stay. I figured that at the end of 3 years, my family, we'd budgeted for 3 years of me being crazy and flying around the world, around Australia. And so it was time for me to stay in one place and my husband to fly around Australia before COVID hit. And so I'm now back in schools. And I really miss the classroom. So I'm really glad to be back helping students to unpick some of those tricky things that students find really hard to unravel. That's the reason I got my grad dip ed. That's the reason why I went into schools, was because I didn't see a lot of me represented when I went to uni. And when I was at Microsoft, I didn't see a lot of females represented there then. I believe it's very different now. And so it was like my little way of giving back and trying to open up those pipelines for women and girls to see those kinds of roles and positions as viable for them, as achievable, that you don't have to be somebody who's wearing a hoodie and been coding since they were 8 years old in order to feel successful. And so while all that was happening, I had some friends who were involved in the Girls Programming Network at University of Sydney, and they encouraged me to come along and bring my daughter. And so I went, and then I didn't stop going ever. And I'm now on the board of the Girls Programming Network. So I've been a content creator and a tutor and a room coordinator. And generally speaking, not in COVID times, every term we run a whole weekend of 150, 160 girls turning up in labs and learning how to program. And we have 3 different grades. So you don't have to know anything to walk in the door, but we kind of give you a very friendly, non-testy pop quiz on the way in, just to check that where your level of understanding is. And then we place you in a room based on that. You get to stick with your friends. You don't ever have to split up from your friends. It's meant to be really social, really fun day. And at the end of it, the guarantee is that every kid is going home with something that works. It may not be the most, bells and whistles product in the world, but it is a thing that makes them feel successful. And I think that's really important. So that's the summary of my life in a very short period of time.
I think it was a good summary.
No, thanks for the story.
Yeah, it's good. Good to hear. I think Kai, you wanted to do the next question.
Yeah, so you switched to teaching, right? And someone asked, why not something else? Or some other subjects?
Okay, so I've been interested in computers and making stuff work and hacking things together since I was in primary school. My parents bought us a Commodore 64 when we were little kids, and I sat there with the basic book and made pretty things appear on the screen. So I think computers have always kind of been in my wheelhouse. I like hacking things together in my spare time, although admittedly as a teacher you get like periods of spare time that are called school holidays, and the rest of your life is kind of packed full of things that you do, and so my social life is now carved out into 2-week blocks during the year, yeah, so I think that computing was something that I was really likely to do, and so I could have done something entirely different. And okay, video.
Video is frozen.
Should I keep going, or should I try and boot out and come back in again?
Maybe boot out and come back in again.
Yeah, okay. See you in a minute.
Technology.
Wait. Might as well just turn off your video and turn it back on again. Don't leave the meeting because we can still hear you.
Yeah, okay. It might work.
Worth a shot.
Okay, video's off.
Suspense.
Yeah. Failed to start video camera. Please select another video camera in settings.
Well, we found the issue. We found the issue now.
Okay, so I will be back in a minute. Yes? Yes.
Yep, no worries.
Sure.
I can play some elevator music.
Mm-hmm.
Sure. What about your AMA? When are you gonna have your AMA? Someone asked you a question.
Let me.
Oh, it's gone. It's gone.
Oh.
You closed that question. Someone asked you a question, Shrey.
What?
I think it was why, like, teaching about teaching something. Are you in the moderator mode? Just go to like the closed questions. You should answer that.
In archive.
Yeah, archive.
Those aren't questions to me. Those are questions about me that I answered. All right, here's our elevator music for now. Oh no, it's an ad. Damn YouTube.
We tried. There was an attempt.
There's 2 ads. Are you serious?
I also just want to note how difficult this is for me because I'm hearing Shrey's like audio feed in my ear, but like very closely delayed.
Shrey, I like that. Have you guys heard the this version?
Yeah.
Let me find it.
I was going to put that one on initially, but I didn't want to be mean.
All right, this is a good version as well. Let me play it. Oh. So that's a great version. There's also the version called Each Pause Just Sends You Further into Paranoia, which is also quite great. There's also a similar one called Paul Sends You Further to Madness. This is what I think about late at night. Oh, this isn't the one I thought it was. Oh wait, this isn't the one I thought it was. Where's the
I feel like maybe let's leave that one there before we like drive away our entire audience.
I feel like meme music is the best thing to do.
I agree. Like meme music is great. Meme music with uncomfortable pauses is less great.
Oh, we're back and we have camera. Nice.
Awesome.
Okay.
Technology is great when it works.
Blame Windows. It required a full reboot.
A system update, like reinstall, like.
I never worked at Microsoft. No.
I think the question that we were on was why teaching?
Why teaching?
Why
yeah.
computer teaching in particular, as opposed to something else?
Okay, so I actually think that the struggle that people have going from not knowing how to program to knowing how to program is really interesting. I don't think you have the same, very definite jumps in other subjects. So you don't go from not being able to write an essay to being able to write an essay in a measurable form. You don't do that. Maths is probably the closest, but we've had hundreds of years to work out how to do maths education, and we've worked out how to make it cyclical so that the students are always building on foundational knowledge and then adding a little bit of foundational to their foundational knowledge so that they are growing constantly. But for a lot of students, the first time they even open a computer to try Hello World is now year 8, which is 13. It's 12 to 13. It's now compulsory for all students in 7 and 8 to do text-based programming. That's not universally implemented as well as I'd like, but it is now compulsory. So that's really late compared to when we first start mucking around with maths. And so I think that there's some quite visible jumps as a teacher when you see a student move from particularly, I don't understand this whole variable thing, to, oh, I understand this whole variable thing. And then I don't know how you can have things that have addressing. Why do things have addresses? I don't get it. Oh, I get the addressing thing now. And so that's really nice to watch. It's really fun to explore. It's interesting to me that every year I kind of build on everything I did last year to try and make it better. So I think that's why computing. Yeah.
Cool, awesome. Yeah, definitely. I think so myself and Tom and I both teach the Introductory to Programming course here at USW. And definitely you see the same sort of jumps and the same sort of thought processes. And it's really interesting that the teaching of computing is moving lower and lower and lower levels. And there's a question about that as well, which is, do you support the idea that programming and problem solving skills should become a basic part of the syllabus as early as year levels as primary school, such as when they start teaching maths? And if so, sort of why?
Okay, so I have arguments with myself about this. I don't have a clear-cut position. I mean, it is already taught block-based down to year 3 in theory. In New South Wales, we have very little time allocated to that. So what actually gets achieved by year 3 students with Scratch in years 3 through 6 is kind of up for debate. If you look at somebody did an analysis of all the Scratch projects, which tends to be our primary area, and 90% of them, or some insane number, maybe 80%, don't have a variable ever defined. So that's not really programming then. It's kind of mucking around with making things move. And so I think that if we can teach it in a way that makes some of this stuff explicit, then that makes it worthwhile. I don't think we just chuck a bunch of numbers at kids and say, go play, see what you learn from that. We actually have a structured approach to these are the bits that need to be the foundation blocks, and these are the bits that need to be built on top of that. And so I see a lot of primary computing is just kind of open up Scratch and let's have a play and see if we can make the cat go meow and see if we can make it move. And I do like experimentation. I definitely have experimentation in my classrooms, but I don't think you can only learn from experimentation. I think you need some of that structure as well. But then how do you resource it? Because no primary teachers has ever done, well, okay, there's probably an exception to that, but the vast majority of primary teachers have never done any computing training. And so their focus is measured by NAPLAN. It's getting spelling and reading and writing and math sorted. And so I think that you would struggle to say, this is the most important thing right now. That said, I think that project-based learning, that where the students actually have an end goal that they have to get to and they're not certain how to do that, and they have to kind of use the teacher as a resource and use tools online as a research and all of these resources together to get them to an endpoint with planning and then with building and then with testing and evaluating. I think that's a really valuable thing. I think that's what so much of post-school is about, that I think that we should spend time on it at school.
Yeah, definitely. That is a really awesome answer. I haven't actually considered the whole teaching Scratch versus actually problem solving. Because my sister, I think she's done a little bit of Scratch, and when she started in year 4, and she hated it. She hated it with such a passion because she's a very artistic person. She likes to just when she draws something, she wants it to appear, right? Whereas like a lot of the stuff she was doing was like there was conditions you had to meet and things you had to move in the right places, and didn't click well with her.
Sure.
But maybe we approach it from a different way. It might actually click well with different people.
My daughter actually hated Scratch, but she programs in Python. So I think that maybe the frustrations of event-driven programming and how they've envisaged event-driven programming and how they get around some of the things like having the same trigger twice. How does the computer react to that? It's a little bit random. And then the kids just see glitchiness and then they get frustrated because they feel like it's them that's at fault. So, yeah.
Cool. Over to you, Tom. I've got my mic muted if you want to ask through here, as opposed to echoing.
So the next question is a really interesting one, given that you're teaching at high school. What is the most important lesson or skill that you think high school graduates should be taking with them into university or adult life?
I don't think it's a lesson that's a subject. I think they need to learn things like resilience and persistence and how to be open-minded and how to listen to other people. And also, although it's universally hated, how to negotiate group work. Because these are things that you actually have to do in life. You can learn anything if you have persistence. You can achieve at any project if you are able to work with others, and you are able to actually change your mind if you're capable of being open-minded. We need a bit more of that in the world, maybe at the moment.
Yeah, definitely.
Yeah, I agree. Especially in sorry, Shay.
Yeah.
No, especially just thinking of like the computing, right? What we're doing, like when you're debugging something, if you don't have persistency, like you give up pretty easily.
Yeah.
So yeah.
And I think Kai as well, because you teach software engineering, which it's a group project, right? The course that you teach, which is, I'm sure you would have seen many interesting groups throughout the years come through.
Yeah. Next question is, why do all New South Wales Department of Education curriculum reviews end in disaster?
Do they? I don't know that I understand the premise of the question. The current curriculum review seems to have been, some things have been well received. The media likes to jump on sound bites, so maybe that's where that's coming from. But the only sadness I have of the current review is that it's delayed my subjects from getting their refresh that they desperately need.
Yeah, kill all the diagram tools. Kill them all with fire. The fact that they're teaching magnetic tape still is upsetting.
Sure.
Tom, do you want to answer the next question? Oh, sorry, ask the next question. You can answer it too, but I'm pretty sure it's not the best idea.
I'm not sure that me answering it is the point, but I can definitely ask something. So there's a trend, particularly online and possibly in the US as well, of pushing jobless people to learn coding with the only motivation to earn lots of money. Do you think that's like a good thing, or do you have thoughts on that?
Okay, firstly, it doesn't automatically follow that you earn lots of money by learning coding. Quite often, the people that learn how to cut code are not the ones that are earning the giant bags of gold. It's the people that tell the people how to cut code, what to do, that are the ones that are taking the gold home. So I do have issues with boot camp type learning. I think that, well, from what I've read and from the experiences I've had, they're very narrow in their view. And so just learning skills to be able to punch out some functions in a particular language without understanding some of those fundamentals means that your skills aren't as transferable, and you haven't learned those wider view of what do I do if my organization is using a completely different language from the one I learned at university. Like in theory, if you go to university and you do a good job and you pay attention in class, then if someone says, oh, by the way, you're going to be using Go in your next project, you'll just work it out because you have those fundamental understandings that syntax is built on top of. And so the syntax is less relevant. But I feel like when you throw somebody through some kind of very fast boot campy type course, that's not as transferable. Now it's not universally true. I've definitely seen and heard of evidence of people who are very successful after those kinds of short-term learning opportunities, and I don't know that they're the rule. I feel like they're the exception. And so I don't know. I mean, it will suit some people, but also why don't we make software engineering compulsory to all students now that we have computers in every single pocket? Probably because it doesn't suit everyone.
Well, that's a really interesting answer. I know that I've also like debated myself several times, like, why don't we make like a programming or like problem solving or algorithms course like compulsory akin to sort of mathematics? And there have been several hours of debate around that, at least with my friend group as well. We have some interesting questions, but I want to move to some more like fun questions because I like fun questions. So I'm going to do a few in a row, and these are what we call like quick shot questions, where you have essentially you have like one sentence to answer, essentially, meaning that you don't get to think and debate with yourself for a while, which often leads to some funny answers. So the first question here is tomato a fruit?
It's a berry.
It's a berry. I've never heard that response ever. Tom's face agrees. Cool. Next question. What is your claim to fame?
Oh, I used to have a claim to fame. I have a claim to fame. I have something like 50,000 watches on a YouTube video. Something like 50,000. It might even, I haven't checked for a while. It might be more than that. But the other day I got 1,000 subs.
Nice.
which is incredible and also a little embarrassing because I haven't made any videos since Shrey was at school. So I need to get on that, find some of that spare time and talk to my people. But I made a year 8, introduction to App Inventor video a bunch of years ago, and apparently it's well explained according to the comments, because thousands of people have used it to pass their uni course. If you're using App Inventor at uni, then I think there's a problem. But yeah, that's my claim to fame.
What skill would you like to master?
Gosh, I'm so bad at baking bread. I really am. I try. I do a lousy job. Pizza I can manage, but any of those, golden sourdoughs that people made during lockdown, and they were passing sourdough mothers all over the country, very jealous, just all the time jealous. I am not able to do that. I'd like to be able to do that.
Cool. Most controversial opinion.
My most controversial opinion. But that's me thinking. I think maybe Star Wars is overrated.
All right. Thanks for today's AMA. We'll see you.
What's Star Wars?
What do you mean, what's Star Wars? I'm kicking you two. Yeah.
I think
So we're starting a new AMA on another
movies.
channel.
Huh. Interesting opinion you have there. That is indeed controversial. Don't know if I agree, but I think that's the whole point of controversial opinions. Next question is alongside the same quick stuff. You mentioned you and your husband had done a lot of traveling around Australia. Best places to go?
In Australia specifically?
Yeah, in Australia specifically.
Okay, so I really enjoyed Tasmania. We did the train ride from Sydney to Broken Hill, and then also drove from Broken Hill around to Adelaide via Mildura, and that was super fun. I just thought it was amazing to see Broken Hill. I've seen pictures of it, and just seeing it in real life was pretty amazing. I really liked the Red Centre. We tortured our children. Well, to hear them speak of it, we really like train journeys, and you can't catch a train from Alice Springs to Darwin unless you catch the super expensive train. And if you get the super expensive train, you can't get off. So you can't stop halfway and kind of explore and get back on the next day. You have to go all the way. And so we didn't want to do that. So we made them catch the Greyhound from Alice Springs to Darwin, which is a very, very long way. But it was particularly torturous because at 3 a.m, the Greyhound buses act as the delivery vehicles for just about everything that goes through the centre of the Northern Territory, because there's not a lot going on. And so they need to get mail places. And so at 3 a.m, they boot you all off the bus in a petrol station in the middle of nowhere. And then the bus goes and takes its trailer to the mail sorting. And this is Tennant Creek. I think it was Tennant Creek. The bus takes its mail trailer to the sorting zone and uses a forklift and does some stuff. And then the bus comes back and we all get back on. But that was super inconvenient and very, very dark and cold. And the children have not let us forget that. So that was, I thought it was an amazing thing to do. And we saw some amazing stars because there's literally nothing in that part of the world. But yes, they did not think that that was where they wanted to be. And then it was very difficult to get back to sleep at 3 a.m. on a bus. So yes, that was maybe not the best thing to do.
That is crazy. I now know I will never be doing that. Wow.
Just fly over the top. That's the recommendation.
Do you imagine if that happened with New Wales trains as well? You just going off, it's just stops shuttle everybody off. You have to wait 20 minutes and get back on.
That's exactly what happened. It was dreadful.
I think, Shrey, we've discovered the next CSE SOC road trip.
It's not that cruel. But yeah, okay, cool. I think back to normal sort of questions. And this is a really interesting question. If you had the time, the money, the resources, the people, what would you do?
It's only a little tiny goal, but I would make the benchmark software design textbook for New South Wales.
What's wrong with Samuel Davis?
Oh, shush. Look, I actually know Sam, so I'm not going to speak ill of him, but I really wish that we had something that was digital, interactive, that it had encouraged experimentation, that it was, regularly updated, that it didn't have giant banks of text. And so that's what I would like to do with my infinite time. And I don't know, like you could pay me while I did it. So that would be the infinite money, right?
I think that's a good call. As much as I loved that textbook, I also did not enjoy it for many reasons. Especially when I think there was a whole 4 pages of magnetic tape diagrams, or whatever they're called nowadays. I can't remember what the actual name of the diagram was.
System flowcharts.
System flowcharts, yes.
Yes, which aren't called system flowcharts anywhere else in the world except in our syllabus.
I've 3 years into uni now, and I've never heard of them outside of software design and development, which I found really entertaining. Cool. Kai or Tom, does one of you want to ask the next question? I've highlighted it.
I'll take it. How did you deal with feelings of uncertainty regarding career changes, and did you ever worry that your previous years of training were being wasted?
Oh, that's an interesting question. Okay. So when you do first year accounting, you hear of the concept of the sunk cost, which means that you should never make a decision based on the cost of a previous decision. So if you've paid for a holiday and you go on the holiday and it's rubbish and you hate it and you don't want to leave because of the money you paid out to get there in the first place, then that is a fallacy. You are actually costing yourself more in the pain of staying with the decision that you made in the past that has cost you something in the past. And sticking with something just because you spent money on doing it or spent time on doing it when it's not making you happy is just not supportable in an accounting sense. So no, I don't regret things. I do constantly feel, and it's good that Shrey's gone, I do constantly feel self-doubt about lots of things, about whether I'm meeting the students where they need to be met, about whether I'm responsible for their 40s out of 100, or if they are, or how much of that should be shared, about whether I am validated to go and stand up at PyCon and talk about the SVG project I did on the side. Those are things that I have self-doubt about. But once I've made a decision, I feel like I've done the hard yards. I've thought through the things. I've talked to the people that I care about their opinion, and then I move on.
Cool. Thank you for the answer. And okay, this question: do you think online courses and boot camps, which you already talked about, for coding will take over uni, especially in this COVID climate? Online learning seems to have risen, and high optional. They added hi Kai Chi in the in the question, so I'm just saying hi.
Okay, so I understand that university did get a lot more online than high school did. We had 6 weeks last year when we were online, and it was torture. It's hard for the... Okay, so that's not true. A bunch of the kids would touch base with us and tell us that they were the happiest they'd ever been in their lives, because rather than having to keep fronting up to a class and switch gears in their brains and try and go from math to English, and they were able to focus on a thing until it was complete, that they were able to not be distracted by people in the class or and things like that, that the noisiness of other students wasn't interrupting their flow. And so some students found that really beneficial. The vast majority of students I spent chasing was because the internet is too huge. a distraction as compared to the noisy kid next to you. And so when you have a choice between being on the internet and being focused on classwork, the internet won. And so it was a lot of work chasing the students who were not getting their work done, who were not contributing adequately, who were not signing in when they were supposed to be. For teachers, it was a lot of work. At university, they tend not to do that work. They just kind of let you sink or swim, right? And so some of those students were like, oh, I have flow and there's not irritating people around me, and they just got stuff done. And a whole lot of other students were like, I don't even know how to do stuff. And they just had to kind of work it out because the lecturer was not checking to see and calling their parents and saying, that person hasn't signed in today. Are they okay? That didn't happen. So I think that online learning suits a very particular type of person. Now, I've only, since I left night college, which was when I did the computer science, all of my education training has been online. I did my grad dip ed through UNE, which is famous for being a very excellent correspondence school. They do a lot of their business through correspondence. And then I did my 2 masters through Charles Sturt, CSU. And they're also, because of the regional university, they are very good at correspondence. There was a lot of reading and regurgitating. That's what online uni tended to be in the education space. I don't know if it's the same for computing. I imagine there's a lot of interacting with bots that auto mark your code. Is that about how online computer science is? And
Somewhat
so
what regular computer science is like as well, even in person.
Yeah, sure. Okay. Yeah, so I think it would be deleterious to move everything online, but I think that the idea of affordances of technology is that we should use them for the bits that make everybody's lives better and not just more efficient. Like the horror stories of people in the US having to be on camera while taking an exam and not being able to look away, or depending on what they were wearing, not detecting on the camera properly. Like, these are just terrible things that shouldn't be happening in a tertiary setting. So I don't want it to be replaced with bootcamp and online. I hope that we get the balance right between what is useful to be online and what is not useful, that the students do need those collaborative skills. They do. And my story for computer science the first time around was failure to connect with other people. And so if you're isolated and doing everything online, then how do you make those networks in order to ask for help, in order to work with your peers? I think it was Arthur C. Clarke said, any teacher who can be replaced by a computer should be replaced by a computer. And so I think you should put it back on the university professors that they don't want to be able to be replaced by a computer, that they want to be adding value that is greater than an auto marker.
Thank you. That's actually a wonderful quote that I'm gonna have to write down somewhere. I definitely won't send it to anyone, but I'll keep it on the book somewhere. This next question is slightly self-interested because I'm actually giving a workshop on the subject next week. But do you have any tips for teaching, and like any thoughts on how people can teach better?
I think that the biggest job in teaching is to work out where the misconception is. There's a PhD dissertation by Sorva. I think his name is, I don't know how to say it, but it's Juha Sorva. He's a Scandinavian computer science education. And this is his dissertation. where he studied a whole lot of people learning computer science, and then in an appendix itemized every single misconception that he had evidence. And I keep that appendix printed and on my wall because it reminds me that it's very easy to forget when you're competent at something what it was that you stumbled over the first time around, and what your students are going to stumble over now. And so I keep these misconceptions close by to remind me that it's not easy for most of my students, and that there are things that they're going to, like simple things that you would think was common sense, like when you're swapping two values, A and B, that you can't just go A equals B, B equals A. You have to have a third space to put one of those values so that you don't overwrite. That is a really common misconception with novice computer programmers. And so keeping those in mind so that you can empathize with your students, because I don't think you can teach somebody unless you can get into the headspace that they're in. Until you can break down what it is that their mental model is doing wrong, you can't correct it. So you have to get inside the heads of the students. And to be honest, with 25 students, that's really hard. I get an hour a lesson, and 5 minutes of that is people kind of shuffling in and being disorganized. And the last couple of minutes is everybody packing up. So I get about 2 minutes per kid per lesson. And so you end up having to work out where to spend that time. You can't sit for 20 minutes with one student and work out where their mental model is broken. But the great thing about using online tools is that I can go in after class and check how everyone's progressing and see where people are stuck, and then target my time better the next day. And that's all I do over and over.
It's really interesting because one of the examples I like to use is that the concept of number equals number plus one is really difficult for some students, especially students who are really good at maths.
Yes.
The fact that you could say some number equals
algebra,
2,
right?
Exactly right. Yeah, it doesn't add up. 0 equals 1. Help. Like there are so many things that are transferable, but so many things that are not transferable. And it's just very interesting to see as well where people get stuck on. And I know that for some of the courses I work with, it's like there's a lot of debriefs of like, oh, we introduced this concept and one student reacted to it in a really strange way, which I think we should take into note for when we teach them in the future. And it's really interesting, just like analyze how people react to it in a non-creepy way. But yeah.
I had a student today, had a moment in class where a student was really cranky, yelling at their group partners and saying they hate this assessment and not listening to anybody at all, just very cross. And it was, I thought, quite an obvious response to there's a particular thing where students who feel like they should be progressing faster than they are being faced by students who are progressing faster than the first student is. And so there's an ego thing there, there's a confidence thing, there's a bit of shame built in, and it's all very hard for someone to face. And just saying resilience and persistence are not very helpful at that time. So I just sat with them, and I didn't chastise. I just spent the time, got them to say out loud what they needed to do, experimented with some list functions. We had a look at some stuff in our online learning platform, had a bit of an experiment. And then you start to see the body language change. The shoulders drop down, and they're starting to make all those ooh and ah sounds that sound like things are starting to move again. And so what could have been quite a difficult situation if I'd gone the normal teacher route of sit down, be quiet, stop being rude to your partners, you're in a group, just pull your head in. It could have escalated further, but able to sit down and quietly just allow them to experiment and kind of direct their experimentation so that it was helping them with the problem they were stuck on, meant that like everything moved in the right direction and they felt successful by the end of the lesson. Now, that's not always what happens, but it was a nice little anecdote from today.
Interesting. Can I jump in on that? Because there's another question I think that follows on nicely. We were talking a little bit a while ago about how the concept of like x equals x plus 1 is difficult. And I know that there are some computing education people who say that because of that, we should be teaching things in like functional languages because there's no concept of assignment. So it makes it closer to what people would understand. Do you have thoughts on whether there are like different languages that we should be teaching or anything like that?
Look, I have mucked around with a couple of languages and I really like Python. I really like it for how similar to English it is, in that that does become a bit of a hump at some points. If you have students who say, who get used to full letter in Word because Python uses iterators and there's a whole lot of magic going on in that for loop. When you're first learning how to iterate through something, then learning that is almost an English sentence for letter in Word is a real benefit. But later on, when you want to do something a little bit more, a little bit different from that, then having to work out what's actually going on with for letter in Word and how that relates to a for loop in a different programming language, or like there's so much wrapped up in that for letter in Word thing that I think that that it does cause trouble down the track. But I think it's a big enough benefit for the really early novices that it's okay to be able to manage those humps when they come. I do struggle with thinking that functional programming languages are better. I know that a number of people I work with don't use the word equals when they are trying to read out the character equals. They use the word equals when they're doing a comparison and you're looking at equals equals. That's an equal comparison. Whereas the other one is an assigned. So we say X is assigned X plus 1, or X gets X plus 1. And there are some programming languages that don't use the assignment equals. And so they use an arrow or something. And it's a little less confusing when compared to algebra. But generally, if someone is competent enough with algebra that that's becoming a problem, that X equals X plus 1 is a problem because it doesn't compute mathematically. Then if you can start getting them to think about it in terms of an assignment versus a comparison equals, we only use equals for the comparison and we use is assigned or gets for a single equals, then I think that gets over that problem without you dragging me to Haskell.
Haskell is great. Oh, Haskell.
No, torture. And also the syllabus. Like I have to teach the imperative languages because that's what's assessed.
So what have you taught Haskell and then assessed them on something else? I'm great.
I have some colleagues who teach Java, which is you can kind of use imperatively, even though it's object oriented. But they learn Java first, and they learn how to make things in Java, and then they kind of have to learn the pseudocode for the searches and the sorts entirely separately, not related to objects, which just takes an extra step. Now you can do it one way or you can do the other, I guess. I have to deal with Pygame or Kiwi because the UI situation with Python is so poor that I have to work with either a really old thing that it does all kinds of wacky things and it's open source, so it has lots of conflicting objects and methods, or a really new thing that doesn't have it's not new anymore, but what was a really new thing that doesn't have enough of a support base for students who need to go out onto the internet and find out how to debug their own code. So yeah, there are issues.
Yep, I remember Kiwi. I'm still not sure if I'm scarred or if I'm impressed. I think a bit of both. But it was fun. I'll put it that way. It was fun. In your video that explained Kiwi, I think is the video that got 50,000 hits because you left it public by accident, I believe was the story.
Yeah, most of my highest hits are accidental publics. Yeah.
Cool. I think I'll take the next question. I'm not sure. I don't think it's been asked yet, but someone is asking, as someone who did a complex subject in a different high school system, so I presume outside New South Wales, it's interesting seeing the highest HSC software design development syllabus. Have you looked at foreign CS curriculums? And if you have, what have you liked or disliked about them?
Okay. So I have looked at the GCSE. I steal a whole lot of stuff because Britain has a lot of their stuff available publicly on the internet, and quite a lot of it still overlaps quite heavily with the software syllabus. So if the BBC are going to make a whole lot of resources, then I'm going to steal them in Australia. And so the GCSE seems to be not that dissimilar from software. I mean, they don't do system flowcharts because they're a bit silly, but the algorithms are similar, the sorts are similar, the searches are similar. So I don't know what their project's like because I haven't ever taught in the UK. So I don't know what kinds of things other teachers in the UK are teaching in terms of a project. I've just undergone training for the IB in computer science. That's the International Baccalaureate. Our school teaches the International Baccalaureate optionally in 11 and 12, so the diploma program. And so I did the training for computer science, and that seems to be deeper in some things and shallower in others. So I really like the option topic on the interrelationship between hardware and software, the binary and data streams and stuff. I still haven't found a way to effectively have enough time to get students actually, sending something to an LED driver or something to make a data stream more real. We tend to use simulators, but I do like that unit a lot, the option topic. I don't like the paradigms option topic very much because it's a bit too light on all the different, it does functional really quickly. It does object-oriented really quickly. There's not a lot of agreement on the semantics of what object-oriented pseudocode looks like. So you're making a lot of it up. But in IB, it's very object-oriented focus. It's been Java mandated. As of next year, they're going to Python as well. So the idea that I could teach objects at 11 and 12 is actually, I think, a really good stepping stone. So I'm looking forward to giving that a go, teaching it the first time around next year, maybe. And also the thing that's really exciting for they've got standard level and high level. For the high level students, they get it. Everybody in the world gets the same case study at the beginning of the year. And the students have to know that case study really well, but they also have to go and research some of the things independently. So they have to know some of the algorithms. Like one of the case studies we looked at was computer vision and using some machine learning neural networks. And so the students had to go and investigate those things on their own, as well as what the teacher walked through in class, so that when they get to the exam, they actually have to write about stuff that's not just written in the case study, but bring in extra information that they've studied themselves, which I think is a really nice approach to year 11 and 12. And I wish we did more of that, student learning for themselves thing. It's a bit more like that AP thing that they do in the US. But AP computer science is not as far as I can tell from the resources I've read, is not as stringent as software design is.
I do feel obligated at this point to defend Haskell by saying that one of the guys who invented Haskell was also one of the people who like made the UK syllabus for computing.
Sure.
Sorry. And we have someone in the chat who was answering some of the questions who was saying that the GCE A-levels CS was very focused on problem-solving concepts and teaching problem-solving that's applicable to every language. There was a lot of lower-level computing stuff like registers, buffers, assembly, but it was very conceptually taught as opposed to like, here you go, here's a C program, please use registers, manually assign registers, which I forgot you could do until recently when someone reminded me. But yeah, that's interesting.
Okay, that's really interesting.
Yeah,
I'll check it out once we get done talking.
Cool. Kai, did you want to ask the next question?
Sure. So yeah, moving on, when or what was the turning point in your career which made you decide to retrain, and what aspects of both careers made you want to switch?
Okay. My mum is a second career teacher. So she was a food technologist when she was straight out of school, did trade in food technology and ended up working at Unilever, testing things like cake mixes and margarine recipes and stuff like that in test kitchens. And then she got married and was expected to leave. Leave work, and so she left work and had kids, and then when we were all at primary school she decided to go back to university and ended up getting the university medal at UC for Teachers College. She did home economics back then and textiles and design teaching. So she was a TAS teacher too. And then when they first invented the computing syllabus, she went and did the night course that they were offering to train people up. And that is still hilarious to both me and my son, who now fixes her computer for her. But it meant that I had someone in my family, someone who I respect as a very good teacher, who is my mum, who'd done this, get your training while it's opportune to get your training, and then you can decide what to do after that. And so having a couple of years at home with kids was a good time to do my graduate diploma. I didn't know that I was going to use it straight away. It just was a job turned up that was part-time, that was computing teaching, that was exactly what I wanted at an independent girls' school, which was exactly, where I wanted to be, not far from my house. So it was like everything kind of landed on the day that I needed it to land. And then next thing, and actually I got interviewed by my old economics teacher who was the deputy at the school that I was applying for. And thankfully we did not discuss how I went in my economics HSC. When she interviewed me. So I think it was knowing that I had someone close to me who'd been a second career teacher. I do have a lot of time for second career teachers. I think that leaving school and going and doing something else and getting some roundness to your career and your world experience has some benefits over going from school to uni to school. Now, that is not bad-mouthing teachers. There are amazing teachers who went from school to uni to school, but it does take them a little while to get to the point where they have experience in the classroom to bring to bear, whereas there's a bit of a jump there when you've had some experience in the world to bring to bear, and they both have their benefits. So that's where my history came from. That's why I decided to that it was an option. It seems like people are questioning my decisions. You should still be in computing, Amanda.
Sorry, Kai, were you saying something?
Sure. Do you want to ask the next
Oh,
question?
sorry. Yeah, of course. Yeah, say computing. You know, who needs
Do you
teachers
want to ask the
anyways?
next question?
Teachers, we don't even need teachers.
Retrain, how did you learn to program?
Anyways, moving on. One of those questions is employers seem to be very picky about asking new graduates for, like, you know, must have 5 years experience in HTML or, you know, advanced programming, blah, blah. If coding is like a more focused on in schools and more made mandatory into a school, which is where looking like it's trending towards that, putting more programming problems on in schools, do you think this will get worse in sort of like asking for more experience out of graduates?
Oh, wow. That's interesting. I hadn't thought about that. I guess it could. I feel like the complaints that I hear about people saying must have advanced HTML skills and SQL and CSS and Java, and like it's just a list of every computing term you've ever heard of in a job app. It is kind of because the people who are putting the job app together don't really know what they want, or haven't really sat down and thought it through properly. The thing that I'm just going to tangentialize this question a little bit. The thing that I'd like to change more than that is the competitive nature of tech interviews. What the heck? No other industry do they say, okay, accountant, here you have an hour to balance these books, go. You don't have a team or anything, just do the thing. I think that that's very high pressure. I don't know that it's doing them any good, and it's definitely keeping women out of places that they should be, because that kind of competitive algorithmic thinking is taught in places like the Algorithmics Olympiad and UNSW ProgComp, and these are competitions that are overwhelmingly male. And so the people that are getting the kind of training to be able to answer those questions in time and express their thinking in time and to solve like quirky, cute computer problems in time that you'll never have to do, will very rarely have to do in your actual job, is actually not beneficial to anyone. And it's just a false way of separating into groups those who can do that kind of puzzle and those who can't. And actually, I've always been the kind of person who can do those puzzles. So I'm not saying this because I feel like I've been disadvantaged in any way. I actually think that my students would be, especially the females, would be overwhelmed by that type of situation. It takes training, it takes confidence. And these are things that I think are stopping females from feeling like they can go for those kinds of roles. And I think that they should change that. And I told them so when I've had any opportunity.
No, that's a really good tangent, and I really appreciate that. We are, you know, we've been trying to discuss more of these things at some of our AMAs. Last week we had on Nikki. Nikki gave us a huge hour presentation, half an hour presentation about her. I can't remember what she titled it, but it was really cool. And we had a really good AMA with her last week, which is really awesome. I think, Tom, did you want to ask the next question?
I'm happy to. How do you get people to come out of their shell and not go on the defensive when you try and explain something that they think might not be right, or that they think might be right and you know isn't?
That's a good question, and I work hard at it. I tend to help them to follow their logic to its breaking point. So I'm not a good programmer. I mean, I'm a good teacher. I don't sit there and do amazing projects in my spare time. I hack things together. I am not, you wouldn't hire me into a programming job anymore. But having seen hundreds of kids do the same problems different ways over a bunch of years, plus also tutoring NCSS and the GPN, and seeing more hundreds of kids tackle the same problems and get the same kind of errors, I am very quick to see where an algorithm, an approach is going to fail. And so rather than tell them your approach is going to fail, you should do it this way, which I think is not the way to teach anybody. It's to give them some tests that are guaranteed to break in their current thinking, and then have them have that moment themselves of, I didn't think it would do that. Why did it do that? And then you can help them step through it and help them find the error that way. So until you can get a student open to accept correction, they're not going to accept correction. So if you go in all guns blazing saying, that's wrong, that has to go, then you've already put them on the defensive. And so saying, have you tested your code with -1? If they aren't very good at tracing the code in their head, then at least with something like Python, they can just run it and then see that it doesn't spit out the result they're expecting and start them on wondering why. I think Derek Muller does a really good job of that. And if you read his PhD dissertation on using media with teaching science, then he talks about the fact that you don't accept new information until you're kind of off balance, I guess would be a summary. And so those videos that he did way in the beginning were in Veritasium, where he asks a whole lot of lay people to answer a question, and they invariably get it wrong because of some, common misconception or knowledge that lots of people hold, even though it's wrong, until they start to think, oh, I've never questioned my belief in that thing before, and now you've got me questioning my belief in that thing. That's when they're open-minded enough to hear the correct information. If you just tell somebody something, then they're not open. You've got to get that opening moment. And so that here's how you're give you something that's going to break your code, and then I'll give you a minute to think about it, and then I'll come back. That's how you do that.
Well, I think that was a really good answer. Tom, did you want to say something?
No, I was just going to thank you.
Yeah, thank you. Thanks, Amanda. You did mention that you don't do projects like outside of teaching in your spare time. This is kind of like an interesting leeway to the next question. What do you actually enjoy outside of teaching?
Okay, so I do little projects. I do little things that don't mean anything to anybody. I talked about how I went to PyCon with my SVG building in Python. So I was just learning more about SVG and was kind of blown away by the fact that it's just XML and that it's just strings, and I could manipulate strings with Python. And so that means that I can get the computer to do all the maths for me, and I can get some pretty funky drawings. So after I did that exploration, I wrote it up and then went and presented that at PyCon. And that was really fun, like to be validated for my little, mucking around in my spare time kind of project. And I like mucking around with electronics. I enjoy the microbit as a teaching tool, but actually I think you can do more stuff with Arduino or with a Pi board or maybe not so much a Raspberry Pi, but something that that is has got a little more guts than the microbit. But we tend to teach microbit at school because it's so extensible. It does allow like jumping in early. Mitch Resnick, who is one of the people that helped build Scratch, talks about low floors, high ceilings, and so that's all about getting a jump in point that's really easy for people so they don't feel overwhelmed. So very little boilerplate code, or blocks so that we can get people in and doing something straight away. But the high ceiling means that it can then grow with them and they can do some amazing stuff with it. I hit the ceiling on the microbit fairly early after I'd been playing with Arduino. So I wanted to have a slightly higher ceiling than it does. But there are a couple of other things that you can then push students into. And I like mucking around with that kind of thing. So making robotic arms and making things move around the house and stuff like that.
Right. That's really interesting. The next question that we've got is actually sort of a throwback to last week as well. You mentioned a moment ago the implications of doing things like the AAO or UNSW ProgComp on diversity. Do you have any other thoughts on sort of diversity in tech and how we can do better with that?
Yeah, why isn't it fixed yet? Honestly, I've been doing this a while. Yeah, so I do a lot of reading on this because I want to try and fix the problem. I don't know if the problem wants to be fixed entirely, so I don't know exactly where to go from here. But in theory, in the readings that I've done, students talk themselves out of maths and tech as options. Girls do quite early, like between the ages of 8 and 10. And quite often it's been put down to a bunch of things, but also I think the fact that girls' processing for language is faster than their processing for maths and technology at that age. And so they feel better at humanities type subjects than they do at maths and tech subjects, even though statistically they could still be better than the majority of the boys in the room. Whereas I think the boys, it works a little bit differently. And so maybe there's a bit of that. Maybe there's still a bunch of societal norms that are like in evidence, that when you watch TV and movies, the super geeks generally are male. I thought it was quite interesting. I watched Zoe's extraordinary playlist on, is it Stan? I don't know. There's been so much TV this year, honestly. The last year, it's all about screens all the time. And so Zoe's extraordinary playlist, although she doesn't seem to do very much work in the show, she is female, cute, can sing, and is also a programmer who leads her team. And it's extraordinary. Like it shouldn't be. But watching it, you're like, oh my goodness, she's female and she's leading a team of programmers. Oh, of course, females lead teams of programmers. They just don't in movie and TV very often. So I think maybe if we get some more of those cultural, entertainment type things that show women in those roles, that will be a turning point. I'm not sure. We've got far more females in medicine now than we had historically. If you look at the AI data that people are polling back in they still use data from very old research, and so in that kind of data, doctors were all male and nurses were all female, and so that influences machine learning algorithms. That's how different it was 40 years ago. And so now we have far more, I think it's even gone further than balance with females in medicine. So I think it's possible to change. It just is, we are a slow industry to change. And I think that it's interesting that even in tech interviews now, people ask, everyone, what's your side project? They want to know about you and what you do in your spare time. And we still have a real problem where females have far less spare time over life than males do. And so maybe asking a female who's taking care of children or elderly parents what their side project is, they might, say their kids are their side project, and they're not going to be up till 2 a.m. making something move around the room. When COVID hit, women all over the world were taking hits on their jobs because it was still considered female work to take care of the kids, and kids were home from school, and so that's not been a good thing for diversity. So I think we've got a way to go yet before we define these roles as flexible between males and females.
Yeah. Sorry, might have been very dead. Yeah, that's definitely true. I think unfortunately, its problem is still not fixed, and we are all hopefully trying to move towards a better future where we can actually fix/improve the problem. Ideally fix, right? A good question that comes up, which is completely unrelated, is bread a recursive sandwich?
I don't think it's allowed to be a sandwich unless it has some kind of
oh no, here we go.
Something on the bread. So whether it's butter or Vegemite or peanut butter or some more detailed filling, it doesn't become a sandwich until there's something there. Otherwise, it's just a pile of bread. Doesn't that mean that a loaf of bread would be a loaf of sandwiches? It's not a loaf of sandwiches, it's a loaf of bread.
Is a hot dog a sandwich?
A hot dog is a sandwich.
What if I had a bunch of croutons and put them in between bread? Is that a crouton sandwich?
That's interesting. That's a different form of bread. Does it have butter on it?
I don't think the croutons are buttered, no.
How do you make croutons?
Wait, I interpret it as other croutons put butter on them. No, they're just croutons.
No, I get that. But bread is the bread buttered? If you make croutons properly, you should be putting fat on them before you dry them. So that would mean that the croutons were buttered or oiled, but I'm wondering if there's any butter on the bread.
Let's say no.
Oh, it's just a stack of fiber then, isn't it?
Now selling stack of fiber for $5.99. Cool.
I want to find the person who builds and eats a crouton sandwich.
It would be quite interesting, I think. It'd be very crunchy.
I think it would be bad. I think you need to go the chip sandwich.
Chip sandwich is good. Hot chip sandwich is actually good.
Yes.
Fully
actually good, right?
It's legitimately good. I want to try it with KFC chips. I feel like that's too far.
We might save you from these bread-based questions.
Excellent.
Are there any issues you have with the way that universities CS education works, or do you have things that you think could be improved?
It's been a long time since I did CS education at uni. What I wish they do now is work with us at high school to develop the pipeline rather than, as I've generally heard happens, ignoring software design entirely as any kind of prerequisite, not giving anybody any credit for knowing what an if statement is, despite the fact that they've just done it for 2 years, and then say something helpful like, I'd like you to forget everything your computing teacher has taught you when they walk in the door, because they have no respect for how high school teachers have taught computing. So clearly that's not everybody, but it is a bit of a feeling we feel snubbed by universities. We have a couple of university professors that work with, I'm the treasurer of the ICT Educators New South Wales Professional Association. And we have a couple of professors that work with us to try and improve professional development for teachers and make sure that they're doing the best thing for their kids so that the kids going to university are the most prepared. But for the lion's share of professors will say, what I want from a high school kid is the highest level of math possible and not to have been, kind of tarnished by any bad computing teaching. So it'd be nice if we held hands a little better.
Do you have thoughts on what you would want that pipeline to look like, or on what you think could change, or is it more like you just want there to be one and you'd ask the professors for thoughts?
Yeah, that's a good question. That puts it back on me and stops me from just whinging. Okay, I think that there should be professors involved in the Professional Teaching Association. I think there should be professors involved with NESA and the development of the curriculum, so that we can make sure that it smoothly transitions to university. And like, university is different in every building, but the kinds of things you teach in CS1 courses are universally the same. Maybe not credit for CS1, but maybe a pass. So you don't have to do CS1. Like, you still have to do the units. You have to make it up with something. But maybe if you've graded a particular way in software design, then you can give CS1 a miss. A lot of students that do software design, they go to their first CS1 lecture and it's on Hello World, and then it's on if statements, and then it's on while loops, and they're like, I'm out. I know all of this. I don't have to go to lectures anymore. And then in like week 10 or something, the lecturers pull out object-oriented, or they pull out recursion, or they start talking about dynamic programming, and the kids that are sitting in the library are missing all of that stuff. I was being nice when I said the library. They're generally sitting elsewhere. So like making sure that we can work together so that the students that do want to study these subjects earlier don't feel like they have to sit through everything all over again for 8 weeks in order to do what they love at university. There is a thing at UTS where they consider tests at the beginning of the year, and if they pass that test enough, I don't know what pass looks like, maybe it's 70, I don't know, but if they pass that test, they can skip CS1 and go on to CS2. They don't, as I said, they don't get the 6 points credit or whatever number of points credit. They have to still do a full degree, but they can do a different course, which is, I think, a good thing and shows some respect for what happened before university. And so working more closely together, like getting teachers involved in CS 1917, getting teachers involved in vetting ProgComp to make sure that it fits with the students, and teachers represented in the Olympiad, the informatics Olympiad, things like that. How do we should learn from the people that are making these things so that we can support our students to be better, because having that pipeline open and flowing is good for all of us.
That's really interesting. Thank you for that. Yeah, there's lots to think about there. Kai or Shrey, you want to take the next question?
Yeah, sure.
Sure. Okay, sure, you go.
You can ask Kai too.
Okay. One of your coolest experiences.
What is my coolest experience in life? Having kids was pretty good.
Yeah, I think so.
I totally loved being a student at NCSS. And I know it probably shouldn't I shouldn't advertise an alternative university summer program when I'm at being invited to do something at UNSW, but you asked the question. When I went the first 2 times to NCSS, and the way it works for kids is that you go and you do one program, and then if you're, a valuable member of the program and also in some kind of percentage of achievement versus social, I don't know, there's some magic algorithm, then you can be invited back and you do the second program. Teachers are welcome to come back and do the second program without a magical algorithm. They're just invited. There's an open invitation. And so I went and I did the first program, which was in that stage, a very heavy Python web-based thing, make a social network of some kind. And then I went back and did the electronics one, which is where they just switched. No, it was still Arduino. We were doing Arduino for the embedded stream. And then the following year, I didn't want to not go anymore. So, so I just went for 7 years. And I missed out last year. Lots of things were happening and COVID was on and they weren't running the embedded stream. So, but I've been going as the teacher coordinator and an embedded lecturer and I don't know, the honorary mum for a while now. And that is one of my favorite things to do over summer. It's a transformative experience. It's really in-depth learning for 10 days. And if you're an adult and you understand your how valuable it is, you tend to, I think, get more out of it than the kids do sometimes, because there's less of that social thing. You're not so working out where you fit in the pecking order because you don't care about pecking orders anymore. And so it's just about, sucking everything you can out of the lecturer's brains and into your own. And we learn slower than you guys do as adults, but I found that an amazing experience. And I really want any teacher who can give up the time to go. The first time I went, the only reason I thought I could do it was because Cubbery was on. Cubbery is the annual, no, not annual, every 3 or 4 years camp where cubs go and be in a field in a tent for 5 days. And both of my kids were cubs. So both of my kids were going to this camp for 5 days and I was going to be on a camp for 10 days. And I figured my husband could cover the gap. After the first year, I said, I don't care what you do, make it work because I'm going back. And so, that was an amazing experience. And I hope it keeps going for a million years longer.
I think promoting NCSS is okay, given that at least 3 people on this call have been to NCSS, I think. Well, tutored, I suppose, yeah. The next question I'm going to ask is, it's related to this topic of teaching, and it's, do you think that everybody should be a teacher, particularly within CS? Do you think that CS people should be teachers? And also, do you think that people should be going into high school teaching?
Okay, two separate things. I absolutely think everybody should be a teacher. I think that your value to an organization is less if you can't transfer your knowledge to your team, to other people. I think that all doctors get trained that they are all teachers, that every doctor is a teacher, and they foster younger doctors, and they teach registrars how things work, and they assist in surgery. And so all of them are trained that this is going to be their life. And I think we need to do that more in computer science. I don't think everybody should be a high school teacher. I think it's not everybody's cup of tea. I think that kids are wonderful and crazy and also super annoying and very exhausting, and you need to be very patient and able to cope with that. I walk the line between being one of those teachers that requires silence in their room, and also somebody who goes out of their brain when 25 people are all talking at the top of their lungs. So you've got to find the way to be in your school, and it is a crazy environment where you work very long hours for 10 weeks and then take a bit of a break, and then work very long hours for 10 weeks and then take a bit of a break. I know some of my colleagues don't seem to work as many hours as I do, and I imagine that's because they're better at this than I am. I still haven't found the perfect program to run each year to make sure that I meet the year 7s where they are, and the year 9s where they are, and the year 10s where they are, and the year 11s and year 12s, and there's about 100 kids and you're trying to do the best for all of them. And every year I end up changing things so that I have to work just as hard the next year. And so some people manage not to do that, and I would be one of them if I knew how. And so I don't think high school's for everyone. I do think everyone should be a teacher.
Thanks. Kai, do you want to take the next question?
Yeah, sure. I mean, I was gonna follow up on that. I mean, UNSW also 10 weeks, 10 weeks of intensive teaching, and then next trimester also 10 weeks.
The difference is that we don't get a break in between.
Yeah, fair.
Yeah. Okay, cool. So what are your thoughts on the Australian education system, particularly this HSC, when you compare to something else that's less intense?
I think we manufacture the intensity. I don't think that, okay, it's controversial, I guess. I have a kid in year 11 now, so we're kind of going through the HSC as parents as well as going through it as a teacher. And I think that first year uni is actually equally as hard as year 12. And that there's a whole lot of stuff that goes on as well as the learning. There's a different style of learning. There's people just talking at you, and a whole lot required from you to just go around and work out how to fill those gaps yourself. There's a whole lot of social stuff going on, whereas generally kids going through year 12 have been in a school for 6 years, and so they have a social network that they can rely on. And I've only worked in independent schools, but I know a lot of department school teachers, and we work pretty hard to meet the kids where they are, to chase down the kids that you know are going to drop the ball, to try and make sure they don't drop the ball, to make sure that everybody knows when the assignment is due, and keep reminding them every couple of days until the thing gets handed in. And so that's a big difference between first year uni, where they give you the date at the beginning of the term and then they just leave you to it. And if you don't get it in, that's your fault. So I think that maybe we build the HSC up as this thing that it isn't. And I think that comes down to the ATAR, and probably that's part of our problem, is that we need to fix that system where everybody gets ranked. And that's it. That's how they get into university. And but alternative systems are not great either. The way they work in the US, where everybody sits an SAT and that rolls up into some magical numbers, and then that gets incorporated with how much co-curricular have you done, how many clubs have you led, and that's what gets you into Ivy League colleges. Which then cost you your entire life's future earnings just to attend. Like, these are crazy systems. And also in the EU, I think there's still some systems where children are identified as being with potential for university or not at the age of 10. And then they go to a high school that is either geared towards getting them into university or geared to getting them into trade school. And while I think it's okay I would really like us to refund TAFE at a level that it used to be funded at. I think that there should be alternative pathways for kids that don't want to go to university. But I don't think that people should be pigeonholed at the age of 10 to work out what their life path is. I think that's too hard too. So I think that all systems are broken and we've yet to decide on one, to come up with one that's better. The IB, I'm looking forward to having a go at that properly, because that is a globalized system. It's all based on some exams, but also some essays. It doesn't seem to be, it's high pressure, but it doesn't seem to be as, just chew up all of the content and spit it back at the examiners in the right order on the piece of paper on the day. I'd like to think it wasn't like that. So I'll get back to you when I know more.
Yeah, I think one of the issues with HSC is not HSC, but as you say, it's the ATAR, right? The fact that we say this is the only year that ever matters in a school system. Like, if you screw up, you will not get into uni and you'll die. Like, this is what we tell kids. And like the fact that you have to know someone who knows someone who knows someone to be like, actually, don't worry about it. It'll be fine regardless. Like,
there's lots of ways to skin a cat. Yeah.
Yeah, exactly. Like, I had to tell my brother, like, you can get an 85 ATAR, you can get a 95 ATAR, you can get a 75 ATAR, you can get a 65 ATAR, and you can probably end in the same place in a few years. It doesn't really matter. Like, the worst case scenario, getting a high ATAR saves you some time, and that's
Yeah,
about
it does save you some time.
That's about it. And there's so much time in the world that I think it's not as big as it's made out to be. And I agree. The system is. Richard Buckland gave a big talk about, what have we redesigned the entire education system to have no marks entirely. Why do we need marks in an education system? And like, there are good parts, there are bad parts. It was very thought-provoking sort of talk that I really liked, and I encourage all the listeners, past, present and future, to listen to. It's really interesting. Most videos in education theory are quite interesting, I found. But yeah.
Those of you watching with a time machine, you should also go check it out.
Yeah.
I feel like there's a flaw in the HSC in that it requires everybody to be generalists. And very few people are actually generalists. That the way the ATAR is calculated, it's moderated against each other. All of the subjects kind of are leveled. And then, so if you're not good at English and you are good at the STEM subjects, that's a very common thing. And yet that can hit you because everything's moderated against everything else. And English is the one subject that everybody's required to do. And vice versa. Most people are pressured into doing some kind of maths, even if it's not their thing. And so if you're not a generalist getting 80s and 90s in every single subject, then it really hits you in your rank. So I think that's a bit of a problem. I wish that was a bit different. I like the Canberra system, where it seems to be internal assessment, project-based, moderated against like a competency test. But that's a really small world, the Canberra pond. And so you can't scale that up to really big, like New South Wales. So I don't know what the solution is. I think reminding students regularly that there are lots of different pathways. My husband completely bombed his HSE. He's possibly going to be cross with me for publicly outing that. There was a girl involved. It was not me. And so he went from school to work, to TAFE, did TAFE at night, did certificate, did accounting, got the diploma, then got a job in accounting, then came to university, and that's where we met at that university that opened. And so it just takes longer. It just takes a really long time to find those alternate pathways. It saves you a lot of time to get a good result in the first place. But also possibly getting a lousy result is giving you an indication that you're not quite ready to go and take on, the highest level of university possible. So I think people need to be able to understand that there's lots of different ways to do things.
Right, thank you. So we're coming up to close to the hour, which means that soon we'll be finishing up. But there's
Gosh.
2 hours. Yeah, we're coming up close to 2 hours.
Wow.
Time flies when you're having fun. But there's a question that we traditionally ask last because it's sort of a catch-all, which is there something that you wish that we'd asked you, or that you wish that you had the opportunity to tell us that you hadn't? If so, what is the question and what is the answer?
I wish you'd asked me. Okay, so I think that I wish that you'd asked me what life would have been like if I'd had a network like this, like a society that I could join, or a girls in programming network that I could join when I was 18, because that's when, you know, things were really hard, trying to get through uni in isolation, working really late at night, working really hard. And so I think that's the question that you should ask, because that's your job, is to be that society for the people like me who are feeling isolated. And I think that everything would have been different. I think I would have been more successful at uni the first time around. I think I would have not met my husband, so I'm okay, because I wouldn't have gone to university the second time around. But also I wouldn't have slogged through all of the things that I did to get the job at Microsoft. And then I wouldn't have found that actually getting all your dreams handed to you when they're not quite all they're cracked up to be directs me into teaching. I think that I'm okay with everything that happened afterwards, but your job is to be that network for the people that are isolated. You need to be out there recruiting for the students who are on their own and they don't even know you exist, or they're not sure how to get in touch, or they're not sure how to ask that dumb question. They think that everybody is better than them, and they don't even know that they can tap you on the shoulder and say, you know, that Haskell thing, it's just incomprehensible, and you can help them. That's your job. Get your subcommittees out there, shake some hands, find the people that aren't in the clique yet, because it changes lives.
Thanks.
Yeah, definitely. That's what we're trying to do this year as well.
Yeah, that was.
We have our lovely Comp Club Summer School, which is lovely and great, as well as the NCS Summer School, alongside several other workshops that we're trying to do for high school students. But also we have a whole bunch of different teams working, and also working on getting those communities, those networks formed inside of university as well. So trying to hit all our bases at the same time, difficult, but we're getting somewhere.
Yeah.
Kai, do you have something to say?
Well, I just wanted to say that was amazing. Yeah, definitely trying to reach out to as many people as we can, and shaking their hands in a COVID safe way, of course.
Definitely. Well, I think that's it for us for tonight. Thank you everyone for coming along. Thank you, Amanda, so much for spending hours of your time with us and answering our lovely question about pineapples and more.
And go look up that tomato's a berry.
Tomato is not a berry. Yikes. But yeah, thank you so much. I think we'll stop the live stream now, Kai.
Thank you, Amanda. Thank you, everyone, for tuning in.